Hello everyone! This video has mobile networks in its name. To me it's more convenient term to be used, but there are some other very close relevant terms which can be used, like cell phone systems, mobile telephony, or wireless telephone systems. It's a subdivision of mobile communication systems or wireless communication systems. People often think it's just about mobile or cell phones, which we commercially use on a daily basis since 1979. But mobile phones are just a small part of overall system, which we plan to talk about. In this video, we will discuss what we can receive from end-user perspective from mobile network, and how this network is internally constructed, what processes are happening inside to deliver quality service to subscribers, how mobile networks have been evolving, and what features are coming with every new generation of mobile network. In the next video, we will discuss how useful and beneficial this information may be for us. I have been working in this industry more than 20 years, and I've started with the first generation of cell phone system, went through all of them till the fifth one, worked in different technical departments of different mobile operators and in technical department of the world's, at some point, largest mobile network vendor. Have hands-on experience in integrating, configuring lots of elements of the mobile network, as well as working closely with R&D department, discussing network issues from specifications point of view. I also conducted face-to-face technical trainings on different topics of cell phone systems. So I assume that my knowledge, which I'm about to share in this video, could save a lot of time for you and helps to briefly understand mobile network from inside out. And we start from some historical perspective. People always have been trying to make their lives better and more convenient. For example, they were trying to move to the skies, and this dream came true with Wright brothers' airplane invention in 1903. Among other dreams, they also were thinking about ways to communicate with each other on a long distance. Eventually, it came in the form without using any wires and therefore not being connected to any specific place during conversation. And one day, commercial mobile networks, the way how we consider them these days, appeared in 1979 with a limited functionality at the beginning, but with a huge potential. As we discussed in our video Techniques and Technology, serious inventions don't come alone from nowhere. Approximately in 15th century, it came time of avalanche-like use of technology and techniques, speeded up during Industrial Revolution of 17th century. And continuing till nowadays. Remember, we discussed that avalanche-like means that one invention helps to bring another one. Consequently, next one comes, and so on. And we had example of Johann Gutenberg's printing press from 15th century. We need to clearly realize that before the printing of books using Gutenberg's press, several inventions had to be made. Relatively cheap and effective raw material, paper, printing ink to be developed, the press to be adopted, probably from ancient art of winemaking. The Roman alphabet had to be in common use. It was universal for Europe with its 26 letters at that time. And all preliminary inventions looks obvious for us now, but they all had initially a long way to be discovered. With mobile networks, there were also several important historical technological steps preceded their appearance. Mobile networks combined several inventions together and used predecessor techniques. Since mobile networks are about fast long-distance communication, probably we can start with Semaphore telegraph. It appeared even before first railroad or any other modern transportation were invented. The fastest long-distance communication channel that time was post service, which used postmen and horses, and therefore cannot be considered as fast enough. And Semaphore telegraph brought a new communication feature, relatively high delivery speeds. One of the Semaphore telegraph system was invented in 1792 in France by Claude Chappe. Several relay towers between end users, sender and receiver points, were built. They had a distance up to 20 miles between each other, so operators at each tower can see semaphore arms on the top of neighbor tower through spyglass. When semaphore arms of one tower start to move, that was a message sending out by using special code. Semaphore was composed of two black movable wooden arms connected by a crossbar. The positions of all three of these components together indicated an alphabetic letter or a digit. Together, letters combined into words and digits into numbers received by operator of the next tower. Once message is received, it should be sent to the next tower using the same principle. So it was a hop-by-hop retransmission of messages from a sender eventually to a receiver through all towers in between. And let me remind the main feature: high transmission speeds. Communication with Semaphore telegraph invention started being much faster than before. Next improvement came with the invention of electrical telegraph. Electricity was known as a natural physical phenomenon with extremely high travel speeds. And one of the use cases is to make electricity work for long-distance communication. There were a lot of experiments and improvements made started from the end of 18th century. And close to the middle of 19th century, there were a lot of commercial electrical telegraph systems in operation in many countries. To simplify, telegraph systems consist at minimum of two electromechanical devices which can send and receive coded signals representing alphabet letters, digits and special symbols through wires they are connected with. Theoretically, we could have 1 or 2 wires per each of 26 alphabet letters, but it turns out to be impractical and eventually only 2 wired systems were mostly in use. 2 wires for all symbols. To send information using just 2 wires, special codes were developed. And the most famous code known till nowadays is the Morse code, having its name by one of the independent electrical telegraph inventor, Samuel Morse. Each symbol in Morse code contains unique sequence of dots and dashes. Please see examples shown to code some letters. The duration of a dash is 3 times the duration of a dot. To separate symbols from each other, period of signal absence was used equal to the dot duration. For example, word "so" would be sound this way: do. How electrical telegraph works? First of all, it uses electricity or electrical energy. In physics, energy in general is a capacity for doing work. Electrical energy is supplied by electric current delivered by electrical circuit. An electric current is a flow of electric charge. In electric circuits, this charge is often carried by moving electrons in a metal wire, or an electrical conductor in general. Electrical conductor is a type of material which allows the flow of an electric current at least in one direction. And metals are good reservoir of electrons in close proximity to each other. Since electric charge is carried by electrons, therefore materials made of metal are common electrical conductors. That's why you can see metal wires in electrical devices. I hope you know that electrons are small parts of invisible for human eyes atoms. And electrons are negatively charged. If not, you can slowly and deeply read yourself about electrons and electricity in appropriate books or watch our videos. We already mentioned that electrical energy is supplied by electric current delivered by electrical circuit. But what is electrical circuit? It's a combination of connected electrical components which have closed loop to give a return path to the electric current. The simplest example of such circuit is a battery connected by metal wires to light-emitting diode, or LED in short, which is used in most modern flashlights and other devices. So electric current in this case has a closed loop to start flowing from negative terminal of a battery through wire, through LED, through another wire to positive terminal of the same battery. Battery and LED are the only 2 electrical components connected by wires in our example. And electrical energy preliminary accumulated in a battery is supplied by electric current discussed earlier. And this energy comes from battery to LED. And LED consequently makes certain work using such energy, which is lightning. That's we briefly mentioned what is electricity. And let's return to the question how electric telegraph works. Sender on one side presses the key based on desired words or numbers to be sent, which are coded into whole sequence of dots, dashes and silence. When key is pressed, electricity is coming out from sending device to the wires. Such electricity signal, once comes to a receiver device, turns into sound, so operator can clearly determine where are dots, dashes and silence, based on mutually known common Morse code table, which we discussed a couple minutes ago. In the simplest implementation, telegraph can be composed with three components: battery, switch on a sender device, and some sound-producing component when electricity comes to its contacts on a receiver device. Switch is an electrical component which can make or break an electrical circuit. When operator on a sender side presses a key, it internally connects switch's contact, making electrical circuit. So electric current can flow from a battery through switch and two wires between sender and receiver telegraph devices to sound device on the receiver side. Instead of LED device from our previous example, electrical energy once delivered to a receiver device makes another work, produces sound. When key is released on a sender side, switch breaks electrical circuits, its contacts no longer internally connected with each other, and we don't have a path, closed loop, for electricity to work. Electricity cannot travel from sender device to the receiver device, and without electricity there is no sound produced by a receiver device. I hope now you have a brief understanding about electrical telegraph's working principles. Implementation of telegraph can be different, but idea and principle are the same. Major benefits from using electrical telegraph compared with semaphore telegraph were compact design without a need to build huge towers and increased speed due to no mechanical movement of a big semaphore arms. And it was a huge step in our historical journey towards our mobile networks because of starting to use electricity. It was still not convenient for everyone and for everyday use because of a need to learn specific Morse code, which doesn't look like human speech. Therefore, logically, the next big step was an invention of a telephone, which allowed to send human speech on a long distance instead of sending coded signals. Voice was sent through wires using electricity, similarly to telegraph, but using different and more complex way of coding voice into electric signals. Several independent inventors can be credited for telephone invention, but Alexander Graham Bell was granted a patent just few hours earlier than anyone else. It happened in 1876. Before discussing telephone, do you know the answer? How we can hear speaker's human voice? In short, because of an energy of generated, transmitted over the air and received air vibrations. Human voice, as any other sound, is a type of energy made by vibrations. When human vocal cords inside a mouth vibrate, it causes movement of invisible air molecules and spreading such movement around through other nearest molecules. This movement, called sound waves, keeps going until these waves run out of energy. Such sound waves could come to membranes inside listeners' ears, causing them to vibrate, which consequently brain decodes as a recognizable sound of speaker's voice. We cannot see vibrations of the air traveling away by our eyes, but for better understanding we can compare them with similar vibrations moving out of the water surface from a place of falling object. Now let's look how telephone between speaker and listener allows to send sound waves on a long distance in a simplified way. Instead of human ear's membrane, we have a special membrane of a telephone on a sender's side. So transmitter of a telephone works as a sensitive electric ear. When sound waves come over the air, such membrane starts vibrating, which consequently generates electrical current in the coils of electromagnet according to membrane vibration. This uses natural phenomenon of electromagnets, which is out of scope for this video. Then generated electrical current delivers from transmitter of one telephone to a receiver of another telephone using metal wires in most cases. On the receiver side, a reversed principle is used. When electromagnet, based on incoming electrical current, pulls diaphragm, the changes in magnetic pull cause the diaphragm to vibrate, which consequently produces sound waves with audible sound of human speech, heard by the listener. Diaphragm initially was a thin circular disc of soft iron and later of other materials. The telephone receiver acts like an electric mouth, and its diaphragm works as vocal cords to generate transmitted human voice. Invention of a telephone was a big step towards mass use of this service, because there were no need to think about speech coding anymore, like it was with telegraph. There were several other avalanche-like inventions made to improve quality and economical characteristics of telephone systems. Among of them was implementing telephone switching systems. A moment ago we discussed example of telephone system consisting just of two telephones. When it started to be popular, there were a lot of users. Large group of telephones started being used. Establishing a connection between any two particular telephones out of a large group was named switching, which is equivalent to connecting. Switching mechanisms allow to connect telephones certainly, rapidly, and economically. A pair of wires extends from each phone to switching equipment in the telephone central office. There are two main types of switching: manual and automatic. In manual switching, a telephone operator makes connections by hand on a switchboard. Now it's a history. Fully automatic switching uses dialing or push-button principle signals to a system which subscriber callers want to connect, and switching happens automatically by equipment without any human intervention. Initially there were mechanical switching systems, but later, and till nowadays, electronic automatic switching systems were developed. Electronic switching works like a huge computer. Next big step on the way to mobile networks was invention of a radio. A radio is a technology of using radio waves to carry information, such as sound for example, by systematically modulating properties of electromagnetic energy waves transmitted through space. You can read yourself separately about electromagnetic energy waves properties such as their amplitude, frequency, phase, or bandwidth. A radio communication system requires a transmitter and a receiver communicating with each other similar to mouth and ear, each having an antenna and appropriate terminal equipment such as a microphone at the transmitter and a loudspeaker at the receiver in the case of a voice communication system. Simplified, when radio was added, we have three types of energy sending from end to end, from mouth of a speaking person till ear of a listening person: sound waves, electric signals in wires, and electromagnetic waves over the air. Initially, when radio was discovered, it was used unidirectional way, sending signals from transmitter to receiver. It's like non-interactive teacher telling a story near whiteboard to students without having any questions back from students. Or like a radio station transmitting music to your radio receiver. But later, for voice telephony service, a radio was started being used bi-directionally, which means both sides can simultaneously send signals towards each other. In technical terms, transition was made from simplex, unidirectional, to duplex, bidirectional signal sending. This is to mimic a real conversation between two persons, when not only one person can talk after another, but one person can even interrupt, meaning start talking at the same time when another is yet speaking. That briefly is about history of avalanche-like technological inventions enabling wireless service, which was initially focused on providing fast, long-distance bidirectional voice communication channels without any wires between end-user devices. Let's wrap up. Semaphore telegraph replaced postmen and horses. Electrical telegraph replaced semaphore telegraph, sending messages nearly instantly. Then telephone replaced coded signal with human voice. Electronic automatic switching automated process of rapidly connecting users on a mass scale. And another achievement was a radio with duplex, bidirectional signal sending initially between two end users. A lot of inventions. Let's move to the next topic, mobile network and its improvements. For mobile network, three important parts should be combined together. First, we have telephone service, sending human voice without any coding from end-to-end perspective, like it was used by telegraph. We can send it over the air in form of radio signals between base station and end-user device. Second, we have automatic voice call connections made internally by special equipment without human intervention, automatic switching system. And the last part, to fairly name system as mobile network, is to provide seamless communication when end user holding mobile device geographically moves but still can continue receiving service, voice call, without interruption. These three major improvements were implemented in wireless networks along with previously mentioned historical technological inventions. You can imagine for simplicity what is happening inside our mobile network from very high altitude. Before seamless communication was introduced, your zone of radio communication was limited by geographical capabilities of transmitting device. For example, if you're listening radio and drive away from radio station, at certain point signal will be so weak that you stop hearing your music and start listening just noise. That means you reach the farthest border of signal reachability. Coverage geographically may look like a circle of some radius with transmitter in the center of such circle. Transmitting and receiving devices which mobile phone communicates over the air named base stations, and they also have coverage limits. If mobile user supposed to go far away from base station, there should be another station to be installed for no interruptions in geographical coverage. And there are hundreds and even thousands of stations actually installed by each mobile operator. But it is not enough to have geographical coverage only. There should be procedures implemented which allow user to quickly switch from sending signal through one base station and continue sending signal through another base station when needed. That would allow mobile users, for example, to drive hundreds of miles on the road, switching from one base station to another, to the next one and so on, and still keep talking within the same uninterrupted voice call. Such procedures named handovers from mobile network perspective. There are other procedures implemented to provide certain separate service seamlessly. For example, to have mobile phone always available to receive incoming calls anytime, regardless of which base station the phone is under radio coverage now. Let's wrap it up. First, telephone service over the air. Second, electronic automatic switching system. And third, procedures for seamless communications when mobile end user moves. All these three components bring mobile network into life. The first commercial mobile networks appeared in 1980s. In December 1979 in Japan, mobile operator entity Docomo, then in Scandinavia, Denmark, Finland, Norway and Sweden in 1981. Mobile networks came to USA in October 1983. Voice service was in the main focus of the first mobile networks. But from end-user services, it was just a beginning. Let's discuss how mobile networks evolved since 1980s. For easier structuring and to set boundaries, mobile networks have been evolving within so-called generations. First mobile networks were first-generation networks, with abbreviation 1G. Fifth-generation networks were launched in 2019. Let's look what was the main focus of each mobile network generation from end-user services perspective. First-generation networks were focused on voice services and surrounded supplementary services. For example, voice conference call between more than two subscribers, or call forwarding to another number based on certain condition. Subscriber is busy, out of coverage, not answering, etc. Second-generation networks on the top of voice and supplementary services introduced SMS, short message service, and data transmission services, including so-called packet data services. The idea underneath is to have more services, and not only voice-related services, available anywhere, anytime, by using the only one and the same kind of hybrid mobile phone without any wired connectivity. In our digital era, any type of digital information, texts, emails, pictures, videos, etc., can be considered as binary coded blocks of data. This data has certain size. The larger the size, the more time is needed to send data through the system of limited capacity. GPRS and enhanced edge technologies, which were introduced in second mobile networks for packet data transmission, allowed to achieve data speeds up to 80 and 236 kilobits per second respectively. That was enough to send MMS, multimedia messages, with some pictures, browse some internet pages, which were usually optimized for watching on the phone screen. Data speed, also named throughput, is a channel capability to send certain amount of data per unit of time, usually second. If your picture size is 800 kilobits, which is relatively small if compared with pictures made by modern smartphones, and if channel allows to have stable 80 kilobits per second maximum throughput, then 80 kilobits per each second and the whole picture could be sent within 10 seconds. With higher speeds of 236 kilobits per second, using edge technology, the same picture could be sent in less than 4 seconds. The higher the speed, the less time is required for sending the same amount of data. It's like a crude oil pipe. The larger the radius of its imaginary cut, the more amount of oil per second can be transmitted. Third-generation networks improved packet data throughput up to 14 megabits per second using HSPA technology. And there was even HSPA Plus improvement, which allowed to have even higher speeds. That also consequently enabled and brought video call service of a good quality, which requires relatively high data speeds. Fourth-generation networks were designed as a pure packet data networks. Even voice calls in 4G networks were implemented with packet data transmission technologies. Totally different approach if compared with reserved circuit-switched voice designed for first-generation mobile networks. Just FYI, alternatively, 4G networks can be used as geographically co-located with 3G networks. If mobile phone supports both 3G and 4G networks and exposed to coverage of both types, then network can be configured the way that voice services can be consumed using legacy 3G networks, while 4G networks to be focused exclusively on high-speed data transmission. Data throughput was increased in 4G mobile networks even more. End user could download with speeds up to nearly 300 megabits per second. That is a significant improvement compared to previous generations networks. And it enabled mobile broadband internet access, where 4G end-user devices could even be connected to computers to provide high-speed data transmission through mobile networks, and could successfully replace home wired internet provider service because of high wireless data speeds. Just FYI, term MBB or mobile broadband access is used on a market with focus on high data throughput via mobile networks. Fifth-generation networks improvements include: first, significantly faster packet data rates with related term eMBB, enhanced mobile broadband. Enhanced is for stressing out a lot higher data speeds achieved compared to MBB ones. Data speed expected to be up to 2 gigabits per second at the beginning and is planned to grow to even 100 gigabits per second. Second and totally different improvement, higher connection density, including so-called massive machine type communication, which means significantly more devices to be connected and consumed services from mobile network at a time. Millions of extra IoT devices were introduced on the top of lots of smartphones. These IoT devices could periodically send small portions of data from sensors and devices, like electrical meters or built-in humidity sensors, etc. To be precise, IoT devices were introduced in the late versions of 4G networks. Third, much lower latency, including so-called ultra-reliable low-latency communications. Let me determine latency in data transmission simplified as delays between portions of information sent in each direction. For example, between smallest amount of data packets. Latency measured in milliseconds. For ultra-reliable low-latency communications, it's not acceptable to see 2-digit numbers in milliseconds. Just few milliseconds are expected. And use cases require such super low latency, maybe mobile emergency medical equipment to send data from emergency vehicle about patient to some hospital, or maybe distant surgery where data transmitted to surgeon not only watching surgery through monitor, but also manipulating equipment during surgery distantly, or vehicle to vehicle V2V communication when cars may exchange important data, for example to prevent or avoid collisions on a road, or vehicle to infrastructure V2I communication, when cars can communicate with street lights to help making decisions or to automatically apply brakes to follow traffic rules and safety guidelines. Do you agree it's critical to have very small delays in packet data transmission for such important use cases? That was in a brief about end-user services improvement from one mobile network generation to another. We have just finished first part of the video, What Mobile Networks. We covered historical milestones, technological inventions as a prerequisites for mobile networks to come. From Semaphore telegraph to radio discovery, Then we mentioned 3 important features which network should have to take mobile network name: telephone service over the air, electronic automatic switching, and procedures for seamless communications. Then we discussed evolution of mobile networks from just mainly voice service in first generation till lots of services including packet data transmissions with extremely fast throughput and ultra-low latency in 5th generation of mobile network. If you are interested how radio resources evolved with throughput increase, see you in the second part of the video. If you are interested what nodes mobile network consists of, then see you in the third part of our video.